What is up, team? I am the Masters Math teacher, and in this video we are going to be exploring what it means to be a function. So jump on board and let's get into it. You might have heard people describe functions as an input-output machine. While this is somewhat true, there is a little bit more to it than that. So let's define a function. The formal definition of a function is a relation such that for each x value, there is only one y value. Okay, so for each x value, there is only one y value. Okay, now remember, what is a relation? Okay, a relation we discovered before. Let's make A. It's the set of ordered pairs. So let's go 1, 2, 2, 4, maybe -1, 4, and 4, 7. Okay, so this here is currently a relation, but let's check. Is it a function? So to check if it's a function, we need to know if there's only one y value for each of the x values. So the x values are 1, 2, -1, and 4. Now, when x equals 1, y equals 2. When x equals 2, y equals 4. When x equals -1, y equals 4. And when x equals 4, y equals 7. Now there's a double up in the y values, but that actually doesn't matter for this definition. We just need to know for each x value, is there only one y value? And that's exactly right. So when x equals 1, y equals only 2. There is nothing more. When x equals 2, there is only 4. That's it. So this here, A, is currently a function. So A is a function. So what does it look like for it to not be a function? Well, let's take another relation, B. We'll also have the point 1, 2. Now we'll have 1, 4, -1, 3, and 4, 7. So this is still a relation because it's the set of ordered pairs. The x values are now 1, 1, -1, and 4. Now for the x value 1, y equals 2, but it also equals 4. So now there's two values for y when x equals 1. There's 2 and 4. So this means it is not a function. So B is not a function because there is more than one y value for each x value. Okay. We can see this graphically too. So let's pull up a graph here. Let's plot A here. So we have the point 1, 2. So about here, 1, 2. We have the point 2, 4, 2, 4, there. We have the point -1, 4, so about here. And we have the point 4, 7, so maybe up here. So let's look at it graphically now. We have for each x value, so we've got the -1 here, it's only hit the y value once. There's one dot down that line. At the x value of 1, again, there's only one dot. There's only one point in which it hits the y value. The next one, 2. Again, all good. It only hits it once. And the same with 4. Okay, let's do that for B and see what happens. So pull up a graph. We're going to plot 1, 2. So 1, 2. Pull out my blue pen. that here. We've got the point 1, 4 up here. Got the point negative 1, 3 there. And 4, 7 again. So that's around here. So let's check again. Negative 1, well that's all good. There's only one y value for the x value of negative 1. But if we check here, there is 2 y values for that point x equals 1. And so that is how we find out whether or not a relation is a function. We do what's called the vertical line test. So if we can draw vertical lines all the way through the relation, we can find out whether or not it's a function. So if it only hits it once, it's a function. So let's do that with some graphs. Let's try y equals x squared, one of our favorite graphs. We know that's a parabola, and it's just our basic ordinary parabola. So it's going to start at 0, 0, and it's going to look like this. Okay, let's try draw some vertical lines. Draw a vertical line here. We hit it exactly once. Draw a vertical line here. Again, we hit it exactly once. If you draw a vertical line anywhere on this graph, it is going to hit exactly once. So this function, y equals x squared, is a function. It's not just a relation, it's a function. Okay, let's try a different one. Let's try the graph x squared plus y squared equals 16. So if you recall, this is a circle with radius 4. The center is 0. So this circle looks like this. I'll grab out my blue. Center here, radius of 4. And connect the dots. It's not a perfect circle, but it does the job. Now let's try the vertical lines again. If we draw a line on 4, well that hits exactly once. Awesome, maybe it's a function. But if we try it again, this one's hit twice, 2 points. Try it again. Again, it hits 2 points. As long as there is at least one vertical line you can draw that hits twice, it means this is not a function. So this graph here, or this relation, is not a function. And we can tell that based on the vertical line test. So now we've figured out how to find out whether or not a graph is a function. Let's take a look at some notation, how to write a function. So let's look back at y equals x squared. What we do to write this as a function is we just substitute y equals f of x. Okay? So we now can write f of x equals x squared. Okay? But why would we do that? Why does that make sense? So what we're saying is a function f takes an x input, so this is your input-output machine, takes an input x, shoves it into the function, and spits out an answer. So this has no impact on the graph, it's just so that us mathematicians can write it a bit easier and use it as an input-output machine. So let's take a look at, say, find y when x equals 2. Okay, that's a lot of words. If it was still for the graph or function y equals x squared, we can now say find f of 2. Okay, all that's saying is substitute x equals 2. So that's 2 squared, which of course is 4. Okay, let's try that again. Instead of saying find y when x equals 7, we can now just say, what is f of 7? 7 squared equals 49. We also have a fancy name for f of x in this notation. We call f of x the image of x under f. So f of x is the image of x under f. Okay, so for this example, when we did f of 7 equals 7 squared equals 49, we can say the value of 49 would be the image of 7. So here, 49, the image of 7 for this given function. The opposite of this is saying that 7 is the pre-image of 49. So we can also use this function notation for algebra. What if I said f of x equals 2x plus take 6? Then I said find f of x equals 0. Well, we know that f of x equals 2x take 6, so we just sub that in, and we get 2x minus 6 equals 0. Then we just get to solve that. Plus 6 plus 6, 2x equals 6, divide by 2, and of course x equals 3. So this is what function notation is kind of used for. It's very helpful when it comes to algebra and substitution. Now you may have noticed that I've just been using f, so f of x. That's because it's the most commonly used. F for function, it makes sense, right? However, it doesn't have to be f, it can be any letter. So we can use g of x, h of x, a of x, any letter you like. However, f, g, and h are the most common. So let's try one with g of x. So what if I said g of x equals 4x plus 16, and I wanted to know when g of x equals 4. Well, I can just go 4x plus 16 equals 4, 4x equals negative 12, and x equals negative 3. Same concept, no difference. It's just the letter that's changed. But for now, we'll keep using f because that's the most common letter. Alright, time for the final thing about functions, and that's how to write the full function definition. So recall when we wrote y equals x squared. That's just our basic equation. Then we wrote that in relation notation. So that was our set of ordered pairs x and y such that y equals x squared given x is an element of reals. Okay, now we're going to write this in function notation. So what we do for function notation is we always write what letter we're going to use first. Okay, so we're going to write f because we're just going to make it a function f. That makes sense. So we start with f. Then we write f such that. So we write that colon, f such that. Now we write the domain. Okay, so we don't have to write x as an element of reals for this notation. We just write what is the domain. And the domain for this is reals. Then we do something a little bit strange. We draw this arrow. And what this arrow means is maps onto. Okay, so all that's saying is what plane of reality are we mapping onto? Are we mapping onto the plane of reals? Are we mapping onto the plane of imaginary numbers? Now in methods, we are always mapping onto reals. Okay, so we always write arrow reals every single time. Okay, so this is our domain, but this is just the plane, so the plane we are mapping to. It is not the range. Careful not to mistake this and confuse it with the range. It is definitely not the range. It is just what plane of reality are we mapping onto. So in methods, it is always going to be reals. So now we have the function f such that the domain of reals is being mapped onto the plane of reals. Now we write a comma, which is essentially just saying where or given. Then we write what is the function definition. So we say f of x equals x squared. Okay, so then we write the actual function. Okay, let's do some examples with that because there was a lot in that. However, it's really not that complex. We just do the same process every time. So let's try a different one. Let's try y equals 2x plus 4. So we're going to take a function. So we're just going to say f. Again, this could have been g, could have been h, could have been a. We're going to say f such that we're going to write the domain. Now we've had no restrictions here, so it's just going to be reals. So f such that reals map to reals again. And then we just write f of x equals 2x plus 4. Okay, so it's just about domain, always writing arrow reals, and the function or the graph, but saying f of x equals rather than y equals like the graph said. Let's take a look at one with a restricted domain. So I'm going to say y equals x squared, where x is an element of -2 to 7. I want you to pause the video and give it a shot. Okay, so all we do, pick a letter. I'm going to say f again, such that we've got the domain. So I'm going to write brackets -2 to 7. Maps to reals again. We always map to reals. Comma, f of x equals x squared. You now have all the skills required to tackle questions involving functions and function notation. So that's it from me. I'd like to wish you good luck, but I know you don't need it. Go smash the mathematics. And as always, if you liked this video, give it a like. If you didn't, give it a dislike and let me know in the comments what I can do better. If you have a topic you want me to cover, let me know in the comments below.